Have you ever heard of the term future shock? It's this idea from the 70s, but it feels like it was written for today.
Oh, yeah.
It's that feeling you get, that vertigo, when the future just arrives way faster than you're ready for.
All right.
Like when you realize the sci-fi movie you watched 10 years ago is now just normal infrastructure.
It is the disorientation of the exponential curve.
Uh-huh.
And looking at the stack of sources we've got for this deep dive, I think vertigo is probably the only word for it.
It seems like a lot to synthesize.
Well, we're pulling from everywhere.
Oh.
The logistics of cryonics, the philosophy of animal rights, all the way to, the mathematical history of economics.
It sounds a little random, but there really is a mission here. We're trying to map out what you could call the architecture of tomorrow. We're looking at how we define intelligence, how we're planning to, extend our own lives to see what happens, and the ethical landmines we might be walking straight into.
Exactly. It all comes down to definitions. What is a mind? What counts as a life? And maybe the big one. What do we owe other beings, whether they're biological or artificial, that might soon be way more capable than us?
So for that, we're pulling from Ray Kurzweil's Singularity Timeline, Marvin Minsky's work on the mind, Peter Singer on ethics, David Edinger on, cheating death.
And we're grounding it all with the economist Paul Samuelson just to see how this all actually gets paid for. So, yeah, let's jump in.
Let's start with Ray Kurzweil. Everyone in tech knows his name. He's the Singularity guy. But I want to go a bit deeper than just the headlines.
Deeper than him predicting the fall of the Soviet Union or Deep Blue beating Kasparov.
Exactly. I want to look at the mechanics of his main argument, his law of accelerating returns.
Which is, I think, often misunderstood. People hear it and think it just means, iPhones get better every year. But Kurzweil's point is that the rate of change itself is accelerating. It's not a straight line, it's an exponential curve. We're not just adding new tools, we're using our new tools to build even better tools faster and faster.
And that curve is getting incredibly steep. He argues that by 2029, that's basically tomorrow, a computer will pass a really robust Turing test.
Not some trick test, but a real conversation where it's indistinguishable from a human. But the date that really matters in his work is 2045.
The singularity.
The singularity, the moment machine intelligence becomes more powerful than all human intelligence combined. And what's wild is how he describes the physical world after that. He talks about something called foglets.
This concept, it's just mind-bending. It's utility fog, right?
Yeah, exactly. Imagine nanobots, just microscopic robots that can link together to create any physical object. You want a chair, the foglets assemble into a chair. You want it gone, they just disperse back into the air.
So the physical environment itself becomes intelligent, programmable.
It sounds like magic, I know. But then you look at something like the latest update on the Tesla Optimus robot, and suddenly that physical manipulation of the world feels a little less like magic.
We should talk about the leap from Gen 1 to Gen 2.
The difference a single year makes is Kurzweil's curve in action. The 2022 prototype was, let's be honest,
It was a guy in a suit, or a very clunky skeleton.
clunky. But the Gen 2 model is doing delicate, tactile work.
The egg video. That's the one. The robot moving an egg from one hand to the other. Now, to most people, that looks like a cute little trick. But from an engineering perspective, that's a nightmare, isn't it?
It's almost impossible to hard code. You can't just write a script that says apply 0.4 newtons of force. What if the shell is thinner? That's why this is such a big deal. Optimus isn't running on a bunch of if-then statements.
It's running on end-to-end neural networks.
Which means it learns the same way we do.
You don't read a manual on how to hold an egg. You hold one, you break a few, you figure it out. Your brain builds a model.
Precisely. It's learning from watching. But this is where we have to bring in someone like Paul Samuelson and the economic side of this. Because if you have a robot that can learn pretty much any physical task just by watching a video, what does that do to human labor?
That's the huge question. The notes mention Tesla's goal is a ratio of 1 robot per human. If you flood the market with billions of workers who just need electricity and never call in sick, the value of labor just plummets.
And that's where Samuelson's work on globalization is, like a flashing red warning light for us. He pointed out that while making things more efficient grows the total economic pie, it also structurally increases inequality if you're not careful.
Because the people who own the capital, in this case the people who own the robots, they capture all that new value.
Exactly. If labor becomes nearly worthless and capital becomes everything, then the gap between the owners and everyone else, it's not a gap, it's a canyon. Kurzweil sees this utopian future of abundance, but Samuelson reminds us that distribution of that abundance is always a political choice.
Which brings us to the mind inside the machine. We're building the body, sure, but are we actually building a mind? We looked at Marvin Minsky's work, and he had a pretty serious problem with how we're building AI today.
Minsky is one of the godfathers of AI, but yeah, he was a huge critic of what we now call deep learning.
Statistical AI.
Right. His whole theory, the society of mind, it argues that the self is basically an illusion, that we're really just a collection of tiny, unintelligent agents or resources all working together.
Like a big committee in your head. There's a grasping agent, a balance agent, a hunger agent, and you are just the result of their negotiations.
It's a very humbling way to look at it. But Minsky's issue with modern AI, the kind in Optimus, is that he felt it lacks true representation. It's all just statistics. It knows egg and fragile show up together a lot, but it has no causal model for why an egg breaks.
It's the difference between a parrot and a professor, right?
Yeah.
Minsky used that great example of common sense.
The string.
Yeah, the string. The child knows you can pull a box with the string, but you can't push it.
Right. A child has a mental model of physics, of what tension is. A statistical model just knows that the words push and string don't appear together very often in its data. Minsky would say that without that deeper symbolic understanding, we're not building real intelligence. We're just building very, very sophisticated mimicry.
He had that great concept, suitcase words. Can you explain that?
Sure. Minsky said words like consciousness or thinking or even emotion, they're just suitcases. We pack all these different complex ideas into one word so we can talk about them, but then we try to build an AI and we get confused because we treat consciousness like it's one single thing.
When it's not. It's memory plus attention plus goal setting.
All of it. So asking, is the Tesla bot conscious? Is, for Minsky, a dumb question. You should be asking, does it have a memory resource? Does it have a self-reflection resource? And so on.
And this gets really interesting when he applies that to emotions.
Yeah, we always think of emotions as this uniquely human, almost mystical thing, but Minsky just saw them as different resource management states.
He defined anger as basically a state where the brain turns down the prudence agents and turns up the take action now agents. It's just a different mode of operation.
Which implies that machines can, and probably will, have something that is functionally identical to emotions. If an AI has a goal, and something blocks that goal, and it enters a state where its top priority is removing that blockage, well, that's anger.
And that is a truly terrifying way to pivot into ethics. Because if these things can have states that function like anger or pain or suffering, do we have to start caring about them? Which brings us to Peter Singer.
Singer's logic applies perfectly here. He's a utilitarian, so his foundation is simple. Suffering is bad, full stop. It doesn't matter who or what is doing the suffering.
He calls it speciesism, the idea that we draw this arbitrary circle around our own species and say only our suffering matters. But a pig or a chimp with the mental capacity of a toddler, their suffering doesn't count.
And for Singer, the line you draw shouldn't be about intelligence or language. The only line that matters is sentience. Can a being feel pain? Can it have a preference that gets frustrated? If yes, you have to include it in your moral calculations.
So, okay, let's connect the dots here. If you take Minsky's view that emotions are just functional states, and you apply Singer's ethical framework, what happens? If a neural net is in a state of high error that is functionally the same as pain, is it immoral for us not to fix it?
That's where the expanding circle of morality crashes right into a wall of silicon. It gets even weirder when you get into ideas like long-termism, which grew out of Singer's work.
That's the idea about caring about future generations, right?
Way beyond that. Effective altruism, which Singer helped start, says we should do the most good we can. If you believe that one day there will be trillions upon trillions of digital minds across the galaxy, then their potential suffering or happiness mathematically outweighs the well-being of the 8 billion of us alive today.
That feels like a really dangerous way to think.
It's dangerous, but it's consistent. It could justify ignoring today's problems to build a perfect digital utopia for the AIs of the year 2099. If they count as minds, and there can be an infinite number of them, their welfare becomes the most important moral project in the universe, just by sheer numbers.
Okay, so the robots might take our jobs, Minsky's deconstructing our sense of self, and Singer's ethics might make us second-class citizens to our own creations. But we still want to see it happen, don't we?
We do. Curiosity is a powerful thing.
Which brings us to the last piece of this puzzle, actually staying alive long enough to witness the singularity. We looked at the interview with David Ettinger from the Cryonics Institute, and I've got to say, he does an amazing job of making it sound less like sci-fi and more like a rational bet.
He calls it the ambulance to the future. That's his core metaphor. He says that we think of death as a single event, but it's a process. And our definition of it keeps changing with technology.
Right. If your heart stopped in 1950, you were dead. Today, we do CPR, we use a defibrillator, we bring you back. Dead really just means the point at which today's doctors give up.
So cryonics is just hitting pause before the damage gets too bad. And the key technology now is vitrification. It's not about freezing. Freezing creates ice crystals that shred your cells. Vitrification turns the water in your body into a glass-like solid.
It preserves the structure. And his whole argument is basically a biological version of Pascal's wager.
It really is. He fully admits the chance it works is unknown. Maybe it's 1%, maybe it's 50%. But the chance of success if you're buried or cremated is zero. A non-zero chance is always better than zero.
There's a legal catch, though, that I found fascinating. You can only be preserved after you're declared legally dead.
Yeah.
So you have to wait for the system to give up on you before you can try to save yourself.
Which leads to what he calls the 2 weeks ago problem. People call him after a relative has already died, asking if they can be frozen. And it's just too late. You need to cool the brain within minutes.
It takes so much planning. And, let's be honest, a certain tolerance for being seen as weird.
Yeah.
I did love his comeback to the creepiness charge, though. Being eaten by worms is much creepier.
Can't really argue with that. But it does bring us back to Samuelson and economics. Cryonics costs money. I mean, not a fortune, around $28,000, often paid with life insurance. But it's still a cost. So who gets to ride the ambulance to the future? The people who can afford it.
So let's try to pull this all together. We have Samuelson, who reminds us that big leaps in progress often come from crisis. He talked about MIT going from a local engineering school, Boston Tech, to a world-class institute because of the sheer urgency of building radar in World War II.
That's such a critical point. This stuff doesn't just happen. It's driven by massive investment and necessity. The architecture of tomorrow isn't being built by destiny. It's being built by specific economic, military, and medical incentives.
So we have those incentives driving the acceleration Kurzweil talks about. We have the hardware starting to catch up with the theory from Tesla. We have a software model from Minsky that suggests our own minds are replicable code. And then a huge ethical warning sign from Singer that we might be creating our own moral superiors.
And in the background, a freezer waiting for anyone who wants to stick around and see how the movie ends.
So here's the final question I want to leave you with. It's maybe a bit darker than our usual thought experiment.
Let's have it.
Okay, let's say Ettinger is right. The tech works. You sign up, you wake up in the year 2099. The world is run by Kurzweil's Foglets and Minsky's superminds. There is no economic use for your labor. The dominant ethical framework sees you as, like, a primitive biological ancestor with a very limited capacity for real happiness. You are a pet, a museum piece.
So you're asking, is just existing enough?
Exactly. Would you still get in that ambulance if you knew for a fact you'd be the dumbest thing in any room for the rest of your existence?
That really turns that future shock inward, doesn't it, I think? I think I'd still take the deal. Just to see it. Just for the view.
You know, I think I'm with you. I'd rather be a confused fossil in the future than just a footnote in the past.
Though I might ask for a user manual before they finish thawing me out.
A very fair request. For those of you who want to dive even deeper, we've linked all the source material. Minsky, Singer, the Cryonics Institute in the show notes.
You should probably read them before the Fuglets get to them.
Thanks for listening to The Deep Dive. We'll see you hopefully in the future.